Everyone. Today we're going to be doing a little bit of poker and a little bit of Zig and a little bit of Websockets. So I've got a working poker hand evaluator and poker player, like the actual table itself. And what I want to do is I want to use my phone to read NFC chips that I have with some cards over here. Yeah, and each one of these cards has an NFC tag on it, so you see on the back. I'm going to scan them using my phone, and using the Chrome NFC browser API, we're going to be able to display some user information, and we're going to be able to interact with our Zig application. So, to summarize, the goals for today is to have that all working. So I want to be able to deal cards like in front of you, and actually have it work. We'll start off by setting up the WebSockets and making sure that that part works. Right, cool. Before then, I'm just going to, check what the stream sounds like. Just making sure it's okay. I'm just gonna turn off desktop audio. We're gonna stop listening. Oh no, I can't. I need to listen to the music. Okay, we're gonna have some echo for a bit. We're gonna have some echo for a bit. We're gonna have some echo for a bit. All right, I think the music could be a little bit louder. Let's try that again. Again. Okay, this is the music now. Again. Okay, this is the music now. Again. Okay, this is the music now. Again. Okay. Good. I like it. So far so good. Let's just have a look at the chat. There we are. Great. Chat is open. Even though that seems a little bit too loud, to be honest. Okay. That's okay. I can live with that. Let's actually go back to the screen then. There we are. I'm just gonna have to update some settings, guys. Oh, and I'm gonna need. I need to on my second screen, my laptop. I need to just grab chats up so I can see them kind of all the time. Let's see. There I am. If you guys have any questions about anything at all, I'll just ask. I'll respond. I'll try and monitor as much as I can, but you know how it is. Sometimes you can't. Here I am. Sorry guys, 1 second. Alright, cool, we're good. Both chats, both Twitch and YouTube are on my second screen. What should we call this? Card NFC to WebSocket to Zig. That allows me to deal poker cards IRL and have a game be visible on my computer. Oh no, I just lost that. Oh no, great. Right, that should do it. It's all good. And okay, let's begin. So, first of all, I already have a fair bit of the poker part mostly done. Right, like I have the setup to deal cards and all that type of stuff. And I was doing it with just the command line for now, but I want to like do that vertical slice. So we're going to use Zap because it has WebSocket support and it's the most up to date. So with Zig, you can fetch the dependency with Zig fetch this here. Do need to add this here. So you can actually just do that module Zap here. Zap mod. Zap mod. Like so. There we can go. Zap. Just delete this. I was already trying some stuff yesterday, but no avail. Let's try this. If we go Zig build, what do we get? Nice. So I should get autocomplete. Lovely. So now I should just be able to go to the WebSockets here. So they have a context as username, a channel. We need to hold on to these. So how does this work? So yeah, we probably do want this, to be fair. The general purpose allocator. Okay. Yeah, standard.heap.general purpose allocator. I have thread safe true. And then the allocator is gpa.allocator. Wait, what's the thing at the end? Oh, it's this. I'm not sure what this does, but global context manager, which is a global variable. Context manager. Dot init has contact list, has a lock. What's this needed for? This all looks quite complicated, to be honest. But for now we will just copy this, and we'll copy a lot of this code. Let's copy a lot of that. So we have a context. We do just want as well, yeah, WebSockets. WebSocket handler. Wait, where's that defined actually? The rest of this? It's not. like the rest is okay now. Oh, wow. Sockets. Wait, what the hell? This example is really strange. It has, yeah, capitals there. Then I have WebSocket handler, WebSocket handler. Yep. WebSocket handler again, WebSocket handler again. Where is that though? WebSocket handler. Oh, it's this here. Let's see. And then this had a global context manager. Alright, a lot of copy pasting here to get stuff to work. We do initialize, so I think that must be to keep, yeah, an entire global state of. Let's have a look. Let's drill down. So it has an allocator, it has a channel. So that's for username prefix, a lock used. I wonder where you used. Just here? Oh, it defers the. Right, and we probably pass the same lock as we do self.allocator.create. Alloc print. Our current context is equal to this. Username, user.channel. Maybe too complicated actually. WebSocket handler.subscribe. Okay. Think we might be able to do this without that. How's stream looking? Stream's okay. Should probably zoom in a bit. That's good. Yeah, this is okay. It was not muted on purpose. I'm not sure how long that's been like that, but thanks for the message. I might not have seen it otherwise. Yeah, I sometimes hit Control M, which is my shortcut for muting my mic, and I kind of forget about it. So yeah, thanks for well, giving me the heads up. Might have forgotten about it for a while. See, what is this condition? Maybe this is thread condition. Let's have a look at that. And that looks interesting. Condition variables are used with the mutex to efficiently wait for an arbitrary condition to occur. It does this by atomically unlocking the mutex, blocking the thread until notified, and finally relocking the mutex. Okay. Yeah, okay. So we have a mutex, we have a condition, a predicate. While not the predicate, c.wait. Okay, so until the condition is like received message. So we can store that in our global context manager, I think. Context manager.init, which has context. Condition. Let's call it that, and then okay. And now when we do init this over here, it's equal to standard.thread.condition. Let's have a look at the documentation again. Condition condition takes in a mutex, which conveniently we have up here. So that's pretty handy. Alright, so we're going to lock until we receive a message. So here we could go context dot question mark dot. Alright, hold on. Context is not as good as we want it to be, actually. Because we wanted to access the condition, do we? Hold on, I'm not quite sure. Let's look at this. For self.condition. So we can wait. We can signal unblocks at least one thread blocked in a call to wait or timed wait until a given mutex. See sequenced before this call with respect to occurs in the same mutex. Okay. So we can do signal on message, and then yeah. Okay, so So let's just pass condition here, which is a pointer to a standard.thread.condition. To be honest, this could be a function, right? That's... No, let's just pass it through. Condition, and let's also do the lock, which is a pointer to standard.thread.mutex. And when we create a new context, here we go, dot lock equals self.lock.condition self.condition, or even, oh, not where I wanted to jump. Here I want the pointers to them, and then on plus can go as well. Dot signal to unblock. So after we do this, what we could do is global context manager dot lock dot condition dot wait. There we go. And there we go. Standard dot log dot info unblocking main thread. Now let's see how that works. Oh, and whilst we're at it, sig implement sig. What is it? Linux terminal. What does control plus C do? Sending interrupt terminals. Yeah. Sig handle sig int. Sig add, and we would want to exit. Whatever. Fine. Do it later. Just do Control D. Alright, the wait expected argument. Okay. Text manager dot lock. Okay, and okay, so you notice it didn't do unblocking main thread until maybe I send a message. Maybe it doesn't. Main thread. Maybe we should put that on its own thread and leave the main thread alone. Might be smart. Yeah. Yeah, I think it is the main thread now. Yeah, only when I go Control C does the main thread run. At some point. Okay. Okay, that's fine. We can definitely put this on its own thread. Sig multi-threading. Yep. So let's do function game thread times void, and here let's do while true, right? Global context manager dot condition dot wait, global context manager dot lock. Not there, there. Like so. We do standard dot log dot info Running game thread. How do I tell the number of threads to run in thread pool? This never actually runs past this, which is maybe concerning. Should it be concerning? Probably should be concerning. So we'll just get rid of you and do so var thread equals, was it try standard dot thread dot spawn. We want to spawn no configuration, just game thread function, and then no parameters to set function. And I don't think we want to really do much with it, do we? Let's do const, why not? Yeah, that's probably fine. Ooh, I can see a lot of thread unsafetiness that we could play with here. A lot of stuff that could go wrong. Yeah, that's probably fine. 156. What's wrong with this? Must be locked. Okay. Well, let's lock, maybe we'll lock ourselves. Dot condition dot time awaited unblocks. Oh, okay, this has to be a different lock. Actually, this can't be the same lock as the memory lock for creating new context. So let's do message like game lock. Game lock. So then there we go, this one. So then when we do handle a message, we signal. And what we're doing here is we should be waiting, unless it's the first time. So the first time we run the game thread will be before any WebSocket connections are through. Or so it should be. It will be. I mean, technically you can get there before. Oh no, you can't, because this app starts after. So we're gonna go and lock ourselves, and we're gonna go say game lock. And we're gonna go ahead and await ourselves. There we go. If I type in hello, running game thread. Type in that again. There we go. So I'm constantly running game thread now. Which, you know, is pretty cool. I like that a lot. I actually should study more on how you make this not terrible. I remember doing an operating systems course at uni, and that was really fun. And we talked about was it non-busy waiting? So yeah, busy waiting, which is just while true check. But obviously modern architectures have way better ways of doing stuff like that. But okay, Zig actually exposes a really nice interface for this. This has not been hard. A little bit of reading, but you know, it's nice. This is a super easy example. I like it. Okay, so that actually has helped us quite a bit, because what we could do is we could keep the game state on that second thread. So basically we take like a lot of this code here, and we're going to put it here. Player 1, player 2, player 3, blah blah blah. Allocator. You can just be stand.heap page allocator. You can just be that. We're going to start the game, and instead of standard in, standard out, which gives me a genetic reader, which is not what I want, so I'm going to have to change this a little bit to be so I have to relock. I'm gonna do something a little bit weird, I think, but see, it will work for now, but it will have race conditions. So I want an atomic value. Yeah. Yeah, I know how right now we only have the one. So we could easily do like last message, put it on the struct. This has been allocated for us, last message, so on message, handle WebSocket message. Is this not freed? Is this freed after? It's going to be freed after, isn't it? I bet it is. Context.this.last. Oh, I keep wanting to like go upwards, like access the global context. Oh, which I can. Whoops. Global context manager dot this message equals message. Yep. I bet this is going to be a bit borked though, because message is probably going to be freed by this. So we won't lock ourselves yet. Oh, this is the deal stage actually. Like, I kind of don't even want anything to do with this. Yeah. Yeah, no. Okay, good. So we get to like do a little bit of more interesting things here. Hold them. Dot setup. Setup actually shuffles the deck, but I want to work with a different deck. So it needs a function called .deal. Could you give a quick overview of what's currently happening on main thread and what's on the game thread? Yes, I can. So there's actually 3 threads, if I'm understanding my own problem correctly. Right now we have this main function that sets up an HTTP server. Right, so we have let's look at this here. We set up the configuration for HTTP server, and then we do zap.start. We give it threads 1 and workers 1. This means that start is going to spawn its own thread. So it's going to spawn. Well, actually, I'm not sure it does spawn its own thread. Let's have a look right now, because what we info after start, because I think it's a blocking call on the main thread by spawning another thread. So yeah, let's if I just close this here, if I show you for a sec. Oh, hold on, last message. So last message can also be null. What is this? Oh, but I still have to say what it is. Or even undefined. No. Not here. Here. yeah, so we got a lot. Yeah, so that actually was a bit weird. Let's just tidy up the code a bit first. So we've set up the players, we've set up this, we've set up this. All of them set up, like, okay, well, that can't all happen. I know we're waiting. Oh, it's because we haven't locked ourselves, have we? Let's just condition dot, or even game lock dot lock. Let's lock ourselves out. Nope. Nope. There we go. So if you see what's happened on the main function is I told Zap to start the HTTP server, and you never actually reached after start. However, if I kind of understand this, if I put 2 threads there, this might. It doesn't. Actually, it seems to be completely blocking on here, which is a little bit surprising. So zap.start blocks the main thread completely. So that's the main thread. It's kind of just blocked by zap.start probably until the program runs out. So you would start this and do other things on the side. So that's why we had a game thread. So we created a thread called game thread, as you asked, that just runs a function that starts up with a couple of players, like just simple structs for our game of poker. So we're gonna set up a game of poker, and basically I want through the WebSocket message to tell what cards were dealt, because I wanted this to be like an IRL poker simulation game. So that's it. That's the main thread is kind of just busy being blocked by Zap. Zap spawns its own thread. To handle WebSocket messages. So it does most of that for us. We don't really have to do that. We just have to tell it what functions to call when we have a message, or when we open a WebSocket, or when we close a WebSocket. So that's it, most more or less. If you have any, ask me any question. If you want, just give me a shout if I'm going too fast or you don't really understand. I'll explain a bit more. It's kind of hard, like as a viewer, to be dropped into like a really big project, so I understand. Okay, I'm gonna continue here. I've locked. I need to wait, and I need to actually refactor a little bit of code here. And I'm not using Git properly because I'm actually just all over the place right now. Instead of deck.shuffle, I don't want to do this. When we create an instance, we want to pass in a struct that has the function. Yeah, that has the function to deal. So we don't want to pass it in deck directly. We will use a function to do that, and then we could suspend in that function, or we could block, and that should be good. Now the thing is, I'm not sure how callback functions will work properly in Zig, because what if I want to access global state? Maybe I can. So let's see. Let's pass it a deal card. And this is going to be a function. Zig callback function. Let's have the Zig callback function. Callback is runtime arguments. Yep. Or I think maybe the better way to do this even is to like expose a deck. So that's like, let's do like pub const genet like dealable deck, which is a struct, and this deck would implement dealable deck for thinking like OOP wise. So this would have a function that just says deal. I'm trying to think. Yeah, function that just has deal. And that would come from our WebSocket message. Right? No, hold on. Let's go back. Let's think about this a little bit more. So basically, I'm here. I want to log, and I want to like set up the player's cards. So really, I could get rid of a lot here. I could get rid of deck altogether. Which maybe I should, you know? Maybe I should do that. Maybe I shouldn't have like this big complicated setup function. Oh, it does make it quite convenient though, to have that. Because we have, like, as you said here, as you see here, like the flop. And then, you know what? Let's strip this back. Let's get rid of this. Let's get rid of the setup function. Let's just have this: print players' cards. We set up players. Then this is literally just like a placeholder for data that we manipulate from the outside. So then we lock, and we could say, well, standard.log.info, last message. And we go, oh, we don't need the /n, do we? We just go global context manager last message here. We assert it's not null. And actually, we could just do this here, and then it will lock. Here we'll wait, lock, unlock, blah blah, do all that stuff. Oops, okay. Yeah, attempt to use null value. Okay. No, but I'm locked. What am I doing being unlocked? I've literally locked myself. Oh, okay. Oh, wrong way around. Okay. Okay, I am locked. I'm going to Websocket. Let's do it in A. D, C. Okay, it's not freed, which maybe is worst, but okay. What we could do is like a. Oh, this is gonna be horrible. So the thread spawned by Zap is listening on the WebSocket port. Yes, yes, it is. Yeah, so it's just an HTTP server, and it will listen for like upgrade requests, and it will also listen for WebSocket stuff, and it's signaling to the game thread when a message is received. Yeah, exactly. So on the handle WebSocket message, we have this. I've said like .last message equals message, so that we can access it later on across threads, and we have context like we've signaled so that then the mutex can be unlocked. And it will kind of go this back and forth, whereas the game thread will lock the game lock. The handle WebSocket message will unlock itself, will unlock it, and then do one more tick, and it will go until, you know, we have a game. What we do have to do is, first of all, this needs to be much more organized, this code, but what we could do for now is in here in Texas Hold'em, or actually, let's do like message to card cards.sig. And we're going to grab cards. And we're gonna basically say like pub function get card. Oh, this is gonna be so annoying. Okay. Cards dot card. Alright, we're back. Could you show the piece of code that runs immediately after the signal is sent? Yes, I can. So that is in our game thread here. So game thread here. So do you see here, first of all, this is where the game lock is locking itself. And we just have a while true loop that basically says wait. Like we've made this condition which basically like waits until the mutex is unlocked, and it will sit on this line of code until it is unlocked. So imagine we receive a message, unlock it, we get to move on to the next bit of code, which is when we get this last message where we print the last message. So yeah, it's in this while loop. It's at the end, just after the condition.wait. So this condition is like a data structure that allows you to do cross-threads synchronization stuff. So you see like condition here, that's it. Yeah. There's the card. Cards dot just card. Yep. Let's do switch. Switch. Oh god. It's gonna be so long. Where are you relocking the thread? I am relocking the thread. Basically on the wait here, right? Yeah, so the wait, yeah, sorry for questions. Like I said, it's a bit tricky to catch up. Yeah, that's fine. So the condition.wait will also lock the thread. So this here, the mutex must be locked. Oh no, hold on, that's wrong. At least the mutex blocks the caller thread, then reacquires the mutex on return. The mutex must be locked by the caller thread. Oh no, there it is here, yeah. It will wait until it's unlocked. And then when we run wait again, it will be locked again. Plus, I'm a GVM developer, so Zig is not my forte, so do at least. Yeah, that's fair enough. I'm pretty sure it's the wait call here that's relocking for us. A blocking call to wait is unblocked from one of the followings. First round wake on random, a future call to signal. Given wait can be interrupted partially. The blocking condition should be checked continuously irrespective of any location for the on the broadcast. Whoa, yeah. A lot of weird stuff that can happen there. Yeah, let's have a look. Game thread, game lock is only mentioned here, and there. So yeah, it's the wait. It's the wait call. We'll also like wait for an unlock signal. I guess we're never actually locking again, to be fair. Maybe we should at that point. Like, why wasn't it? You know, that was just kind of a little strange. So we have we unlocked, deadlock detected. Oh, so it is already locked. So maybe yeah. Okay, so it was the wait. It's the wait here. Yeah. Yeah, it was the weight. The weight basically locked us again. Cool. Okay, so now I'm going to do something really annoying, which is just cars.card factory rank. Oh, rank dot sounds good. Ace and cars dot suit dot. Let's start with spades. And actually, this one. What was it? Vim increase column of numbers by 1. Can't remember. Control A and Control A. So if I have like also 50, 2, 3, 54. That's just 1 over. Yeah. Let's do this. What was it? G, Control A. Control A. Oh, Vim. Column of increasing numbers. G, visual block. Extend the selection to the bottom of the screen. Now. Enter literal 0. No, that's not what I want. There was an actual thing that does this. Semi on topic. Are you streaming on Twitch? I think the delay there is shorter. I am. I am. So might on Twitch. Twitch.com/JohnCosta27. Yeah, same thing. John Costa 27 on Twitch. If you'd like to prefer to be there, I'm watching both chats, so I'll be able to respond. Anyways, G plus GA. So G plus Control A. Into the visual lock, select all the numbers starting from the second row. Control A. Is it Control A? It's not right. Doesn't seem right. Maybe something different with UM. Oh yes, this will do it 100%. You can go into visual mode, increasing script, convert a block. Control V into a column of increasing integers, such the column then into I. To replace selection, the first line number is used as a starting value. Sure, okay, you know what? 7. Also cannot switch on strings. Sure, const. Let's just parse that then. Standard equals import standard. Equals standard.fmt.parse int to like u16. Doesn't really matter. Sure. The buffer and the base, yeah. Catch and reachable, and we go card string. Just go num. Just say num. Nine. Okay. Macros it is then for now. And then like this. I need a couple more. 50, 51. Actually, yeah, that's it. Cool. Let's go num. Oh, I should have done one more thing. Oh, it's okay. 2, 3, 4, 5, 6, 7, 8, 9. Ignore that, ignore. 10. Jack, Queen, King. So ace, 2, 3, 4, 5. Oh, I said give again. 6, 7, 8, 9, 10. Jack, Queen, King. Let's repeat that 13 times. Great. Spade, spade, king. So spade, let's go hot. Let's go club. And diamond, like so. I think that's correct. Yeah, I don't see you on Twitch, Solomon. Yeah, I think I have played chats open. Anyways, so we have this function now, get the card. That we can go on our main.zig, message to card equals import dot slash message to card.zig, const get card equals message to card get card. Okay. So then we can do all of that here. Bar counter every time we go around, do plus or equal 1. And we go P1. Well, actually, let's just not do counter. We can hardcode this for now. Let's do P1 dot. Oh wait, hold on. Dot players 0 dot c1 equals get card. Let's do const mess card equals global context message dot last message dot question mark card 1 1 2 2 3 3 4 4 5 5. Get card, and each time we do this. Made it. Hi. Let's see again. Only then do we print last player's cards. Yeah, we could go through again. We do have to lock each time. card equals that. Like this. Yeah, this is nice, isn't it? We'll write a loop in just a sec. Let's see. Switch must handle all cases. Yeah, true. Else unreachable. Love handling it like that. Value of type, value of the cards ignored. Oh, yes. Return the switch. Yep. Okay, so if I go 0, 1, oh, I have a failure. 1. Okay, that crashed. Invalid character. Oh, is it the /n? It's gonna be the /n, isn't it? So, cool. Wait, zig slice array. Obviously, I want to remove the end, so it's going to be 0 dot dot string of length minus 2. One invalid character. Wonder why? What do you think this is? Standard dot debug dot print string. So if I go 1, what do you think it is? Here. Just 1. What if I do 0 dot dot string dot length minus 2? I wonder what the invalid character is. This has to be a new line character, right? Did I even save that? Maybe I didn't save. Hold on. Let's check again. Let's check again. If I send a 1 here, okay, yeah, it's panic. Oh, because it's the new line character is just 1 character. Yep, that's correct. I think 1. Here, 1 invalid character still. Not sure why. It's the character 1. Is there a space or something? What am I missing? Length. So that's the length of the total thing without removing the... Could you print a string and ask your ETF? Oh, yeah, that's such a good idea. Length is 2. Sig print string in UTF. Oh, I think if we do any, we'll be able to do it. I think sig defaults to bytes, right? Yeah. Yeah, there we go. So then we get 49. We'll print this here. Which is correct. We sent the number 1. ASCII table. Pretty sure that's... Yep, 41. Sorry, 49 was it? Yeah, number 1. So then parse in... Oh no, I'm silly. There's a -2 there still. There we go. That was it. Yeah, good tip, thank you, chat. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When did I tell it to stop? 2, 13. 1, 2, 3, 4. Oh, that's weird. 13. Why 13? If I got it repeated somewhere. 3, 3, 2, 2, 1, 1, 0, 0. Alright. 2 of spades. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, perfect. Works. It actually works. Very nice. And if I hook this up to my phone and I had the tags properly written, then this would also work, which is very, very cool. I might, however, leave that for another day. Because I'm quite happy with progress so far. So 1, 2, 3, 4, 5, 1. Yeah, okay, hold on, but this is weird. Why did I do it twice? Ignition dot. Oh, I just waited at the end for like no reason. I don't need to wait on this very last one. Nice, nice, nice. I am loving this. This is so nice. Why are they in order? Well, because I just typed in 1, 2, 3, 4, 5, 6, 7, 8, 9. You know, like the point is not for us. The point is for the WebSocket to dictate the order, right? So imagine like I have my deck of cards that I'm dealing. If it happens to be in order and all the numbers go 1, 2, 3, 4, 5, 6, 7, 8, 9, then so do the cards. Yeah. Oh, it just looks like input map. Then yeah, makes sense. Yeah. It's just this long function here. Yeah, because the I guess I'll explain like the whole objective is to have them actually go. I'll go full person for this. The entire objective is to have like a deck of cards like this that has the like NFC tags on the back like this, and you can just scan these with your phone. Like that's pretty easy. And with Chrome on Android, you can actually use NFC on the browser, or you could build your own custom app, which I don't really want to do, but you could. So, but I'm just going to use browser because well, it's what I know. It's just the easiest. So then you scan that, you send that through a WebSocket connection, because you don't really want your phone to be connected to like the machine that you're running this on. You could run that on your phone, but you know, I thought this would be like a cooler way of doing it, more interesting. Scan the card, send it through a WebSocket, Zig will read it, we'll be able to play the game alongside. And yeah, that's it. It would also allow you to run the game remotely, like as a service almost. So you could just only have your phone. We could run the things for you, like the game, show you the status and all that. It would be really cool. And the goal is to basically just be able to play poker in real life, and you know, see what we did in certain nights, like what I did in a certain hand against certain friends, so that we could like analyze and stuff. The other really interesting thing is we could have a hybrid game of poker. Like you could deal the cards, you could like face down, like you deal the cards face down, but the scanner will pick it up. Like you scan, deal, scan, deal, scan, deal. So imagine that I'm dealing to a person that isn't here. Like one of my friends is at university, let's say. You deal the card, and on their computer screen, they can see what cards they have, and they can play accordingly. So that's the ultimate goal of this, is to have like a hybrid game, which would be really cool, because that's usually what we literally say we want. It's like, oh, wish I could have like a camera so that we can all like play even when we're not there. So that's the goal. Any questions on that? Yeah, feel free to ask. It's kind of interesting. It's just like a fun project. Never played with NFC tags and stuff like that. Yeah, it's an interesting game. Okay, let's wrap some of this up. So we have our WebSocket stuff. We have our player. Okay, let's just I can't bear this one here. We should be able to dictate the number of players that kind of exist, but hey, let's do an inline for 0-5, and we do let's just do this here, and we do this here, bop, 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 index, and we do have to do this again, like so, for C2. But at least our code is much simpler. Let's do 4 players. Let's do 3 players even. Oh no, 4, because I want an under the gun spot. Best viewers on. Oh right, okay, you're one of them. Good shout. Thank you very much. I am not sharing my screen. God, I suck at this sometimes. Still fairly fresh at the streaming thing, as you can see. There you go. Screen is shared. You can all see OBS. Mic is going. Cool. Yeah, thanks man, you're being super helpful. I love actually super, really helpful. Alright, let's do this here. What's the create? Is that blind sales? Blind sale. Alright, let's try just one last time. Build. Reconnect. Let's do 1, 2, 3, 4, 5, 6, 7, 8. Oh, and then we waited. This could. We could actually do anything here. It doesn't matter because yeah. There we are. Although player 1 got the 9 of spades. So we got 2 of spades, 9 of spades, 4 of spades, queen of hearts. Oh, right. Index here. And I guess we could actually just wait a 4. Like this. Pretty sure that would work. Oh no, it wouldn't, because last message. Yeah, we can just do that. Declare it outside. Oh, we can do var card like this. There we go. 1, 2, 3, 4, 5, 6, 7, 8. There we are. 2, 3, 4, 5, 6, 7, 8, 9. Awesome. Feet. WebSocket card dealing. Using Zap for handling HTTP upgrade to and WebSocket connections. Deal cards through WebSockets. Next steps, play the game like actually through like a WebSocket server. Which, you know, after we do all this, you could print what players have, and you could like ask them what to do and stuff. But that's for a different stream. It is 9:15. It is 9:15, so I'm just gonna tidy up the office, kind of relax for a little bit before I have to go to bed and my job in the morning. I enjoyed this. This was very fun. How long did we stream for? We streamed for an hour and a half. So, you know, still pretty rookie numbers in terms of how much we are streaming. But you know, we'll get there. Hour and a half, pretty good for a VOD as well. Right, well, Solomon, you get a shout out. You've been really good. Thank you for all your stuff. I might have just had a completely muted stream if it wasn't for you. I hope I catch you in another stream. Well, Wait, hold on. Am I not getting chat? I just realized chat is not appearing on the stream, is it? Hold on, let me test. So if I type in hello, testing here. Do I actually get chat appearing? I'm sure I do. Like I have the I should have it coming up. Oh, it's there. It was just behind everything. Right. It would come up here then. No? Let's try again. Let's try that again. Oh yeah. No, it's there again, isn't it? Yeah, okay, cool. And then here all the chat appears. Okay, nice. If you hit, do you wanna try giving a follow? I should have that set up as well. Oh no, maybe I don't actually. I don't have the follower notification. I'll do that at some point. Just to chat for now then. Okay. Yeah. Thanks, man. See you all, guys. See everyone later. Everyone who's watching the VOD, if you've made it through. Yeah. Catch you soon. Bye bye.